Graphing a derivative. We can use the graphs to understand the relationship between function and derivative function. Here we have a graph of our function, that is under root x, and this is the graph of a derivative function, that is 1 divided by 2 under root x. Okay, first we notice that f of x is increasing. First we notice that the function f of x is increasing for all values of x in its domain. Furthermore, as x is increasing, the slope of the tangent line to f of x are decreasing. We can see here the slope of the tangent line. This is the slope of the tangent line is decreasing as x is increasing, and also the derivative of the function is decreasing as x is increasing. This is the derivative of the function at each point. So we expect to see a corresponding relation decrease in f prime of x. Here we see that the derivative of the function, is also decreasing as x is increasing. So this is the relationship between the derivative function and the function. We also observe that the derivative of the function at x is equal to 0, and that is infinite. Here we also see that the slope of the as limit x approaches to positive, this is the right hand limit. As x approaches to 0, f prime of x, which is equal to positive infinity, and this means the slope of the tangent line, that is infinite. Okay, at x is equal to 0. So corresponding to a vertical tangent to f of x at 0, at this point at x is equal to 0, the function has a tangent line. Okay, the function has a tangent line at this point, and the slope of the tangent is infinite. When the function has a vertical tangent line, then the function is not differentiable at that point on which the function has a vertical tangent. Okay, so this is the relationship between derivative function and given function when the function is increasing. Here we see when the function is increasing, the derivative of the function is decreasing as x is increasing. Okay, and at x is equal to 0, the function has a vertical tangent, and at that point the derivative of the function is not exist. Now we write a Matlab code to graph a derivative function and a given function. Matlab code. This is the initial command clc clear all and close all to clear screen and clear data, save data, and close all figures for. Okay, here is the format short command, and x is equal to linspace 0 to 3. This is the domain of x, and linearly space command we use for linearly space between 0 and 3, and this will give us 100 points between 0 and 3. Again, for capital X, linearly space command 0 to 4, and h is equal to 0.0001. Here we have this is increment. Okay, and this is the given function sqrt, and we f is equal to use f of x. We find the value of the function at each x, and this command for white color, for setting the figure color white, and now we use for loop for I is equal to 1 to length of x, and this is the derivative function. This will give us a derivative function, and this is the slope of the tangent line at each point, and this is the equation of a tangent line. Okay, then we plot our derivative function, x versus derivative function, and x versus a given function, that is f of x or under root x. Okay, and x versus derivative function, our derivative function is 2 under root of x. We find the derivative function by using this formula, by using definition of a derivative. Then we plot our given function x versus given function, and x versus derivative function, and then the tangent line x versus, this is the capital X for length for a tangent line, and this will plot our tangent line at each point with green color, and this will plot a red circle on a graph of the function. This is the red circle on graph of the function at each point. Okay, this command is used to plot x-axis like that. This is the x-axis for -1 to 4, and y-axis 0 0 on this on x-axis with black color, and this command used to plot y-axis. Okay, and at y-axis x is 0, and y limit of y is -1 to 5. Okay, so this is again black color, and the width of the line is 2. The width of the line, this is the width, and this is the width of the line is 2. Okay, this line indicate the given function, and this line indicate the derivative function, and green line indicate the tangent at each point, and this is the derivative of the function. This red circle indicates the derivative at each point, or the slope of the secant line at each point, because we know that derivative is equal to slope of the tangent line. Okay, the legend command is used to define a function derivative function tangent at each point, and this is our legend command. Okay, so this is the x limit. This command is used to set the x limit, and this is y limit. This is our x limit -2 to 5. Here we have a 5, and y limit -2 to, this is -2 to 5. Okay, then we use a command and draw now, and we end our for loop. Okay, this is the Matlab code to plot a function and derivative function and a given function. Okay, so we check this function, and as x is increasing, the tangent, the slope of the tangent line is decreasing. This is the behavior of a tangent line at each point, and this is the derivative of the function. We also see that as x is increasing, this tangent, the slope of the tangent line is decreasing, and the derivative is also decreasing. And this is the graph of a derivative function, and this is the graph of a given function. As x is increasing, the function is increasing as x is increasing, but the derivative of the function is decreasing. We also see that the derivative of the function is positive as x is increasing. As x is increasing, the function is increasing, and the derivative of the function, that is 1 by under root 2, which is 1 by under root 1 divided by 2 under root x, which is positive for all values of x, as x is increasing from 0 to we have used limit in 0 to 3. This is our domain for, or the limit for x, as x is increasing from 0 to 3, and the derivative is positive, and the slope of the tangent line is decreasing as x is increasing. We also see here the derivative of the function is also decreasing when x is increasing. Again we see and this the behavior of our given function, that is, as x is increasing, the slope of the tangent line is decreasing, and the derivative of the function is also decreasing. This is the derivative of the function decreasing 0.3 and so on. This is decreasing as x is increasing. Example: find the derivative of a given function, that is f of x is equal to x square minus 2x, and the derivative of this function is f prime of x is equal to 2x minus 2. And this is the graph of a given function, which is f of x is equal to x square minus 2x, and this is the graph of a derivative function, that is 2x minus 2. Okay, so observe that f of x is decreasing for x less than 1, and this is we can see, and this is for this one, x is less than 1 and x is greater than 1 over here. Okay, so we can see that the function is decreasing for x less than 1, and for these same values of x, the derivative of the function is also negative, this which is also decreasing. We can see that the derivative of the function for x less than 1, that is negative. Okay, and for the value of x greater than 1, the function f of x is increasing and the derivative of the function is positive. Here we can see that the function for x greater than 1, the function is increasing, and the derivative of the function is positive for x greater than 1. So also for f of x has a horizontal tangent at x is equal to 1, and the derivative of the function at 1, which is 0. Here we have a function where the derivative of the function f prime of x which is 2x minus 2. If we put x is equal to 1, 2 minus 2, which is 0, and at this point we will see the derivative in the tangent at x is equal to 1 will be horizontal. So we see the tangent at each point of the function. Here we can see that the derivative of the function is a negative from x less than 1, and the tangent line is also the slope of the tangent line is also negative over here, and we will see when x greater than 1, the derivative of the function is positive and the slope of the tangent is also positive. At x is equal to 1, at this point the derivative of the function will be 0 and the tangent will be horizontal at this point. This is the derivative is 0. Okay, so now the derivative is positive, the slope of the tangent line is positive for x greater than 1. So this is the relationship between a graph of a function and the derivative of a function.